Mathematics is fun, you can do it. Hello everyone, welcome back to our channel. In today's video, we will be discussing about relations and functions. And we will be dealing with different activities involving relations and functions. So, let's get started. Hello everyone, so we are going to discuss now relations and functions. So this is part of your lesson in mathematics, senior high school. So let's start with relations and functions. You are going to learn to analyze and graph relations, find functional values, and there are vocabulary words that you will encounter during this video lesson. We have ordered pair, Cartesian coordinate, plane, quadrant, relation, domain, range, function, mapping, one-to-one function, vertical line test, independent variable, dependent variable, and functional notation. So let's start the discussion now. So we have here relations and functions. Now, this table shows the average lifetime and maximum lifetime for some animals. Now let's take a look at this table. We have the cat, cow, deer, dog, and horse. So the data can also be represented as ordered pairs, meaning you have here the average lifetime for some animals. Then we have here the ordered pairs for the data are 12, 28. For cow, we have 15, 30. For deer, we have 8, 20. 12, 20 for the dog, and for the horse, you have 20, 50. So the first column is the average lifetime, and here is the maximum lifetime for some animals. So the first number in each ordered pair is the average lifetime, and the second number is the maximum lifetime. So in this case, if we come up an ordered pair, let's say we have 20, 50 for the horse, for instance. 20 is the average lifetime, while 50 is the maximum lifetime. Okay, so this is just simply an introduction of relations. Now, the data can also be represented as ordered pairs. Okay, so we're done with that. So let's now discuss relations and functions. So based on the previous example or introduction, we had talked about ordered pair. Now that is very common because you are familiar with that when you were still in junior high school. So you can graph the ordered pairs below on a coordinate system with two axes. So you have here, for these are ordered pairs, and you're gonna make a graph considering this is your y-axis and this is your x-axis. Then the maximum lifetime will be in your y-axis and the average lifetime will be in your x-axis. So remember, each point in the coordinate plane can be named by exactly one ordered pair, and that every ordered pair names exactly one point in the coordinate plane. The graph of this data, the animal lifetimes, lies in only one part of the Cartesian coordinate plane. The part will all positive numbers. As we all know, these are all positive numbers, so we will be dealing the quadrant 1. The first quadrant we're in, our y and x coordinates are both positive. So in this case, let's say 12, 18, verse 12, 28 for instance. 12, 28 meaning our x is 12. Then let's start with the smallest, for example, the smallest x ordered coordinate. Okay, so you have here 8. What is the partner or the pair, the y, corresponding y coordinate of 8, we have 20. So let's try to check if we're going to plot the point. 8 is somewhere here along the x-axis. 8 is somewhere here and 20 is here. Okay, so that this dot represent, or this point represents the ordered pair 8, 20, this one. Okay, so let's proceed to this one, 12, 28 and 12, 20. So we're actually looking at the first at the x coordinate. So for 12, 20, 12 is somewhere here and our 20 is here. Look at that, 12, 20. So this point is a representation of the ordered pair 12, 20 in this Cartesian plane. And we have also 12, 28. So they share the same value of x, and 28 is somewhere here. Look. Okay, that's 2 units below 30. And we also have 15, 30. It's very easy for us to locate 15, 30 on the graph. 15 in the x coordinate along the x-axis. This 15 and then go up. 30 is here. So this is our point for the coordinate 12 at 15, 30. And lastly, we have the ordered pair 20, 50. Here's our 20. Here's 20 and 50 is here. So these are the points that corresponds to these ordered pairs. Okay? So that's it. Now, the Cartesian coordinate system is composed of the x-axis, which is the horizontal, and the y-axis, which is the vertical, which meet at the origin 0, 0, or which has an coordinates 0, 0, or ordered pair 0, 0, and divide the plane into 4 quadrants. You can tell which quadrant a point is in by looking at the sign of each coordinate of the point. So take a look at this one. This is quadrant 1, wherein the ordered pairs are both positive. This is the x coordinate positive, y coordinate is positive. Quadrant 2, when the x coordinate is negative and y coordinate is positive. And the quadrant 3, where both y and x coordinates are negative, and quadrant 4, wherein the ordered pairs are positive and negative, or the x coordinate is positive, the y coordinate is negative. Now the points on the two axes do not lie in any quadrant. Okay. So in general, any ordered pair in the coordinate plane can be written in the form ordered pair x, y. So what is then a relation? Okay. So now let's discuss the concept of relation. Now a relation is a set of ordered pairs. And the domain of a relation is the set of all first coordinates. We call it x coordinates from the ordered pairs. The range of a relation is the set of all second coordinates, or we call it y coordinates from the ordered pairs. The graph of a relation is the set of points in the coordinate plane corresponding to the ordered pairs in the relation. Now, given the relation, okay, let's have an example. The set of ordered pairs, we have 2 and negative 6, 1 and 4, 2 and 4, 0, 0, 1 and negative 6, 3, 0. Okay? Since we have the braces, this is a whole set. So the state, if you're asked to state the domain is actually all the x coordinates. So we're going to look at the x coordinates and arranging them in ascending order from least to greatest. So you have 0, that's why you write here 0, and then 1, you have that, then 2, and also 3. Okay, so this is our domain. as you've noticed, or we can just write 2, 1, 2, 0, 1, but 1 is already repeating. We need to write it once. That's why 1 appears once in this set. Okay, then you have 3. Then arrange it in ascending order. That's why you have this set of domain 0, 1, 2, 3. Now how about state the range? Okay, still from least to greatest. Let's start with -6, followed by we have 4, 0, -6, and 0. So 0 and -6 appear twice. So we'll write it once. So you have -6, 0, and 4. Okay. Note again that these braces are the symbol for set. When writing the domain and range, do not repeat values. So you have to take note of that. Okay, let's proceed. State the domain and range of the following relation. The set of 2 and -3, 4 and 6, 3 and -1, 6 and 6, 2 and 3. So the domain would be 2, 3, 4, and 6. Again, you arrange it in ascending order from least to greatest. And you have to write the domain. If the x coordinates is repeating, write it once. Okay? So for the range, we have, take a look at the y coordinates. We have -3. We also have 6, -1, 6 repeats. Then you also have 3. Okay? So again, arrange it in ascending order. -3, -1, 3, then 6. 6 appeared twice, but we will write it once. Okay, proceed. So state the domain and range of the relations shown in the graph. So as you can see on the graph, there are 5 points plotted on this graph. We have -4, 3. The set of -4, 3, we have -1, -2, we have 0, -4, we have 2, 3, and 3, -3. So the domain is, we have -4, -1, 0, 2, and 3. And the range is -4, -3, -2, 3. Notice that they are always arranged in ascending order. Okay. Next. Relations can be written in several ways. We have ordered pairs, table, graph, or mapping. Okay, let's start with the ordered pairs and the table. So, if you have this set, 3, 4, 7, 2, 0, -1, these are ordered pairs of -2, 2, -5, 0, and 3, -3. And this would be our table. Okay, the corresponding table of these ordered pairs. So you will write x because these are the x coordinates or domain, and these y coordinates are the range. So x would be your values of your domain. You have 3, 7, followed by 0, then -2, -5, then 3. And you also have for your y, you have 4, 2, -1, 2, 0, and 3. Okay? So I hope you were able to follow. Let's proceed. How about mapping? For mapping, you have to create 2 ovals with a domain on the left and the range on the right. The elements are not repeated. Connect elements of the domain with the corresponding elements in the range by drawing an arrow. Okay, let's have an example. So, as you've seen in the mapping, this is the set of ordered pairs, and we're gonna show how it is presented through mapping, how the relation is presented through mapping. So, as you can see, if 2 is repeating, you have to write it once only. Okay? So, you have here 2. Then, followed by 1. 1 is also repeating, you write it once. Followed by 0. Okay? Then we have 3. Then next will be from 2, this is our domain. And this is our range. Or this is our x coordinates and this is our y coordinates. So for 2, that corresponds -6, as well as 2 here. We also have 4. So this is negative 6 and this is 4. So the arrows from 2 goes on 6 and negative 6 and 4. Now let's proceed to 1. 1 is repeating, which has corresponding y coordinate of 4 and negative 6. So 1 goes to negative 6 and goes to positive 4. And 0 does not repeat, 0, 0. So you have 0, 0. Okay? Then 3 has a coordinate, has y coordinate of 0. So you have 3, 0. Okay, let's proceed. Now in summary, relations is a set of pairs of input and output values. There are 4 ways to present or represent relations. Again, it can be expressed in ordered pairs. You have input and output. You have x and y, wherein your input is the domain or the set of x values. Your output is the y coordinates or set of y values. Or through mapping diagram, your input again is negative 3, 3, 4, and output is 4, negative 1, 3. Okay? The arrows show how to pair each input with an output. You could also have the table of values. You have your input, your x coordinates or your domain, and your output is your y coordinates or your range. Or you could also present a graph by plotting the points. You have this one is negative 3, 4, and this is positive 3, negative 1. This is 3, negative 1, and this is 4, positive 3, and this is 4, negative 1. Okay, so let's proceed. Now, functions. The objective is to recognize whether a relation is a function or not. So how are we going to know if a certain relation is a function or not? Okay, let's proceed. So what is then a function? Okay, so a function is a special type of a relation in which each element of the domain is paired with exactly one element in the range. Furthermore, a set of ordered pairs is a function if no 2 ordered pairs have equal abscissas. Abscissas meaning the x coordinates or your elements in your domain. Okay, that's abscissas. A mapping shows how each member of the domain is paired with each member in the range. So you have here the set of the ordered pairs negative 3, 1, 0, 2, and 2, 4. Okay, so the domain is negative 3, 0, 2, and range is 1, 2, and 4. Now, notice that this is called one-to-one correspondence because the domain does not repeat and also the range doesn't repeat. Okay, so this is one-to-one correspondence. So let's proceed. Now state the domain and range of the relation shown in the graph for a moment. Okay, so is the relation a function? So we have here the relation is, we need to write all the ordered pairs based on this graph, and then we're going to identify the domain. The domain would be negative 4, negative 1, 0, 2, 3, and the range is negative 4, negative 3, negative 2, 3. We are asked to answer as to whether or not this relation is a function or not. So each member of the domain is paired with exactly one member of the range. So this relation is a function. Okay? So meaning, as you can see, the domain doesn't repeat. Here, no x values or x coordinates is repeating. Okay, let's proceed. Okay. So for instance, this one, 4, 12. These are ordered pairs 4, 12, 5, 15, 6, 18, 7, 21, and 8, 24. This is considered as a function. For you to identify or determine if the certain relation is a function or not, focus your attention on the x coordinates. This one. This is our domain or x coordinates. If the x coordinates does not repeat, or none of the coordinates, x coordinates is repeating, then it is automatically a function, regardless if the y coordinates is repeating. So you are going to focus your attention here. So 4, 5, 6, 7, 8. None of them repeats. So here, it's not a function because you have 4, 12, 4, 15, 5, 18, 5, 21, 6, 24. 4 repeats, or 4 is repeating. So it's not a function. Okay, let's proceed. How about this mapping? Is it a function or not a function? Now let's take a look at the example of a function through mapping. So you have 10, 2, 3, 3, 4, 8, 7, 4, 5, 8. So what have you noticed with the x ordered pairs, or x, or the domain, or the x coordinates? It doesn't repeat. Okay? This one is not a function. Remember, the first oval, okay, the first oval consists of your values in your domain, and it will be written as once even if it's repeating. So as you can see, you have 10, 2, 3, 3, 5, 4, and 5, 7. So this consists of two ordered pairs with 5 as the x coordinate, meaning to say 5 is repeating. We have 7, 5, and 2, 5. So this one, this x coordinate 5 is the reason why this mapping is not a function. Okay, let's proceed. How about this one? Okay, none of the x values or domain is repeating. Here, 1 is repeating. It consists of ordered pairs, 1 negative. There's no negative 0, by the way, so you disregard the negative sign. And 1, 15. Okay, so this is not a function. How about this one? This is an example of a function because you have 1, 2, 3, 4, 5, 6. It doesn't repeat. Okay, none of the x values is repeating. And this table of values for the x, let's take a look. 1, 2, 1, 3, 4, 5. So 1 is repeating. Okay, 1 repeats twice. So it's not a function. Okay. How about this one? This is an example of a function. You have negative 3, 0, 3, 8, negative 10. Because none of the x values is repeating. And this is not a function because negative 2, 0, negative 2, 7, negative 8. Negative 2 is repeating. Okay, let's proceed. Relations and functions. You can use the vertical line test to determine whether a relation is a function. So what is vertical line test? So you have here, if no vertical line intersects a graph in more than one point, the graph represents a function. So this one. Okay, considering this is your vertical lines. Okay? So if you're going to draw a vertical line all throughout this graph, if it only intersects at one point, then the graph is a function. So in this example, in this graph, this is a function. However, this one, if some vertical line intercepts a graph in 2 or more points, the graph does not represent a function. As you've noticed, although it intersects one point here, but if we're gonna draw more vertical lines towards this side, then the vertical line will gonna intersect 2 points. Okay, so this is not a function. Okay, let's proceed. Now the table shows the population of Indiana over the last several decades. We can graph this data to determine if it represents a function. So you have the year for the first column and the population in millions for the second column. Then we plotted this table of values in this graph for the population of Indiana. The x coordinates is the corresponding years, and this one will be the population in millions. So these are the corresponding graphs, and by using a vertical line test, this ruler actually, if we're going to examine using the vertical line test, Notice that no vertical line can be drawn that contains more than one of the data points. Therefore, this relation is a function. Okay, I hope that's clear. Now let's proceed. Let's proceed to examples of graphs, either it's a function or not, to determine if a function or not. Okay, this one is a function using vertical line test. This one is not a function because if we're going to draw a vertical line here, it will intersect 2 points. This one is a function. This is not a function, obviously. This is a function, and this is not a function. Okay, so it's very clear for the concept of vertical line test. So for activity number 1, you have to answer this in your activity notebook. Identify if the given relation is function or not. Okay, so we have here number 1. You have to answer this one. This is number 2, number 3, number 4, number 5, number 6, number 7, 8, 9, 10, and 11. Okay, and number 12, we have this mapping, the input and the output. Number 13, we have table of values, the x and y. Number 14 is a graph. Number 15 is a mapping. So you have to write if it's a function or not a function. You have to copy, by the way, the problems or the given graphs or the given mapping or table of values. Okay, let's discuss some concepts now. Determine whether each relation is a function. You have, if you've noticed, this is a set of ordered pairs. If we're going to present this 1, 2, and then there's a process f of x, then you have 3. Then if you have 3, then it has a process or function, then you have 0. 5, it undergoes a process and you have the result. 4, then it will undergo a process and you have 3. So you have here every domain is different. As you've noticed, every domain is different. Therefore, if the domain doesn't repeat, it is a function. So number 2, we have here 4, 1, the set of ordered pairs. 4, 1, 5, 2, 5, 3, 6, 6, 1, 9. Is it a function or not? It's not a function because 5 is paired with 2 numbers. Look at this. 5, 2, 5, 3. Okay, let's proceed. Is this relation a function? You have 1, 3, 2, 3, and 3, 3. It's a yes because none of the x values is repeating. Okay, the vertical line test, or we call it pencil test. If any vertical line passes through more than one point of the graph, then that relation is not a function. So are these functions? Take a look at this one. The graph is the red one and the vertical line tests are the black one. So this is a function. This is not a function. This is a function, by the way. Again, this is a function because it intersects one point. This is also a function because the vertical line only intersect at one point. And this is not a function because the vertical line intersect 2 points. This is a function, not a function. This is also not a function. By the way, the graph here, the red one is the vertical, this one. So it overlaps the vertical line test. Okay? The graph is here. So it's not a function. It intersects an infinite number of points. Here, it's a function because it only intersects one point to the vertical lines. Is this a graph of a function? Yes, because if you're going to look at it, if you're going to draw a vertical line test, we are going to apply that. It will intersect at one point only. Okay, now relations and functions. When an equation represents a function, the variable, usually x, whose values make up the domain is called the independent variable. And the other variable, usually y, whose values make up the range, is called the dependent variable because its values depend on x. Now, function notation. When we know that a relation is a function, the y in the equation can be replaced with f of x. F of x is simply a notation to designate a function. It is pronounced as f of x. So the f names the function. The x tells the variable that is being used. Note, letters other than f can be used to represent a function. Example, you could also have g of x is equal to 2x plus 1. Now, this is now the function notation. Y is equal to f of x, meaning y is the same as f of x. Y is the output, f is the name of the function, and x is the input. Okay, given f of x is equal to 3x minus 2, find f of 3 is equal to 7. So it means to say that the input is 3. And this is the function. F is the function. So you have 3x minus 2. And you have here 3 times 3, that's 9. Minus 2 is 7. So 7 here is the output. Okay? If you have f of negative 2 is equal to negative 8, because you have here the input is negative 2, meaning we're going to replace x with negative 2. So you have 3 times negative 2, that's negative 6, minus 2, that's negative 8. So negative 8 is the output. Okay, let's proceed. Given h of z is equal to z squared minus 4z plus 9, find h of negative 3. So negative 3 is the input, the function is z squared minus 4z plus 9. And every time we encounter z, we're going to replace that with negative 3. So this becomes negative 3 quantity squared minus 4 times negative 3 plus 9. Negative 3 quantity squared is positive 9. Negative 4 plus, times negative 3 is positive 12. And 9, just copy that one. We have 9 plus 12 plus 9. That gives us 30. Hence, h of negative 3 is equal to 30. Okay, I hope everything is clear so far. Okay. Now, given f of x is equal to x squared plus 2 and g of x is equal to 0.5x squared minus 5x plus 3.5, find each value. So, if you're asked to find f of negative 3, since we're talking about f, we will be using this function. So, you will write f of x is equal to x squared plus 2. Since you have your negative 3 is the input, you are going to replace x with negative 3. Is equal to negative 3 quantity squared plus 2. You have 9. That's negative 3 quantity squared is 9. Then copy plus 2. 9 plus 2 is 11. Therefore, f of negative 3 is 11. Now, how about g of 2.8? So, we are going to use, since it's g, the function g is this one. So, we have g of x is equal to 0.5x squared minus 5x plus 3.5. Then, we have here g of 2.8. So we are going to replace x with 2.8. So you have 0.5 times 2.8 quantity squared minus 5 times 2.8 plus 3.5. That gives us 3.92 minus 14 plus 3.5. And you have g of 2.8 is equal to negative 6.58. Okay, let's proceed. Given g of x is equal to x squared minus 2, find g of 4. So, the answer would be, if you have here g of x is equal to x squared minus 2, you can solve it mentally. If g of 4, you have x, you replace x with 4, that becomes 4 squared minus 2. 4 squared is 16 minus 2, that gives us 14. Okay, let's proceed. Given f of x is equal to 2x plus 1, find f of negative 8. So, we're going to replace x with negative 8. So, 2 times negative 8, that's negative 16, plus 1, the answer is negative 15, this one. Let's proceed. Value of a function, okay? If g of s is equal to 2s plus 3, find g of negative 2. So, the same procedure, we have to replace s with negative 2. We have 2 times negative 2, then copy plus 3. 2 times negative 2 is negative 4, then you have plus 3. Negative 4 plus 3 is negative 1. Therefore, g of negative 2 is equal to negative 1. Okay, let us continue. If h of x is equal to x squared minus x plus 7, find h of 2c. Now this time, the input has a variable. This is 2c. Okay, so you expect that the final answer will have a variable too. So you have every time you encountered x, you're going to replace that with 2c. So you have x squared, you have 2c quantity squared. Negative x, you have copy the minus sign, then x is 2c, then plus 7. Quantity 2c squared, you distribute the exponents, that becomes 2 squared, c squared. 2 squared is 4. So you have 4c squared, copy minus 2c plus 7. So this is now the final answer. We can no longer combine because they are not like terms. Okay. Now the value of a function, we have if f of k is equal to k squared minus 3, find f of a minus 1. So as you've noticed, we're dealing with a binomial. We are going to replace k with a binomial a minus 1. So the input is a minus 1. So you have f of a minus 1 is equal to k squared. You have a minus 1 quantity squared, copy minus 3. So remember the FOIL method. So you have here the quantity of a minus 1 times the quantity of a minus 1, copy minus 3. Using FOIL method, you have a squared minus a plus 1 minus 3. Combining like terms, you have a squared minus 2a minus 2. Okay, let's proceed. Now, relations and functions. Graph the relation y is equal to 2x plus 1 and make a table of values. So, considering this is your given, for instance, you are given y is equal to 2x plus 1. If you're asked to make a table of values, you'll start with negative 1, 0, considering you choose this one. You choose negative 1, 0, 1, 2. So just simply solve for the value of y if x is negative 1. So y is equal to negative 1. If x is 0, y is 1. If x is 1, y is 3. If x is 2, y is 5. So it's just like these are the inputs and these are the outputs based on this function. Remember that y is the same as f of x. Okay? Okay, for a moment. Remember, y is the same as f of x. So after that, you're going to graph this one. So negative 1 is here. 0, 1, this is the point. 1, 3, this 1, and then 2, 5. Okay. So next would be find the domain and range. As you've noticed, the domain is the set of all real numbers. Why is that so? Because it is a graph, a line graph, as you've noticed, and it is a slanting one, and the arrows goes on forever both sides, meaning to say the domain or the set of x values would be all real numbers, and the range, same is true with the range. It's going up also with arrowheads, so meaning range will also be all real numbers. Okay, number 4. Determine whether the relation is a function. The graph passes the vertical line test. So this is a vertical line test or a vertical line. If we're going to draw as many as vertical lines as we could, it will only intersect at one point. So for every x value, there is exactly one y value. So the equation y is equal to 2x plus 1 represents a function. Okay, let's continue. How about this one? Graph the relation x is equal to y squared minus 2. So the same procedure, we can actually choose x values of 2, negative 1, negative 2, negative 1, 2. Then y values we're going to solve. If x is 2, what is our y? So we're going to just simply substitute the values here. Y would be negative 2, negative 1, 0, 1, and 2. Then afterwards, we are going to plot the points here. So you have 2, negative 2. This is here. 2, negative 2. Then negative 1, 1. This one. Then negative 2, 0. negative 1, 1, and 2, positive 2. And we are going to connect all the points. We come up with a graph like this. Okay. So, next would be find the domain and range. The domain is all real numbers greater than or equal to negative 2. Because the arrows of this graph is facing this side. So, there's no way that the graph will going to turn back. So, this is our domain. All real numbers greater than or equal to negative 2. So, the x values is going there. Greater than or equal to negative 2. And the range are all real numbers because this will goes on going up and this is going down. So the range or the y values will be all real numbers. And then for number 4, determine whether the relation is a function. The graph does not pass the vertical line test because this vertical line intersect 2 points. For every x value except x is equal to negative 2, there are 2 y values. So the equation x is equal to y squared minus 2 does not represent a function. Okay? So this is not a function. Okay, let's proceed. So the vertical line test actually is if a vertical line is passed over the graph and it intersects the graph in exactly 1 point, the graph represents a function. Okay, now does the graph represent a function? Name the domain and range. This one, obviously it's a yes. The domain would be all real numbers and the range should be all real numbers. This one, this graph, this is also a function because if we're going to draw a vertical lines, it will only intersect 1 point. So the domain will be all real numbers. The arrows are going to that direction. While the range is y is greater than or equal to negative 6. How does it? Because if we're going to count, this is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So y is greater than or equal to negative 6. The y values is going up. Greater than or equal to negative 6. There's no way that it will go down. Okay? Because the arrows are in that direction. These 2 directions. Okay, let's proceed. Does the graph represent a function? Name the domain and range. So, this does not represent a function. The answer is no because if we're going to draw a vertical line here, it will intersect 2 points. And the domain, we have x is greater than or equal to 1/2. Here is 1/2. Okay, the domain is the value of our x. Okay, because the direction of the graph is going to the right direction. And our range, since it goes that direction and this direction going down and going up, so the range will be all real numbers. Okay, this one, obviously it's not a function because if we're going to draw vertical lines, it will intersect more than 1 point, like 1, 2, 3, 4, 5, even 5. Okay, so the domain will be all real numbers because of the arrows. Okay, it will cover all real numbers and the range is also real numbers going up. This is going down. Okay, let's proceed. Now this time you have to answer this in your activity notebook. This is the second activity. You have to evaluate each function. Number 1, h of t is equal to the absolute values of t plus 2 plus 3. Find h of 6. By the way, absolute values meaning you are going to disregard the sign. Number 2, g of a is equal to 3 times the quantity to the power of 3a minus 2. Find g of 1. Number 3, w of t is equal to negative 2t plus 1. Find w of negative 7. Number 4, g of x is equal to 3x minus 3. Find g of negative 6. Number 5, h of n is equal to negative 2n squared plus 4. Find h of 4. Number 6, h of t is equal to negative 2 times 5 to the power of negative t minus 1. Find h of negative 2. Number 7. F of x is equal to x squared minus 3x. Find f of negative 8. Number 8. P of a is equal to negative 4 to the power of 3a. Find p of negative 1. Number 9. P of t is equal to 4t minus 5. Find p of t minus 2. Number 10. G of a is equal to 4a. Find g of 2 of a. Number 11. W of n is equal to 4n plus 2. Find w of 3n. Number 12. W of a is equal to a plus 3. Find w of a plus 4. Okay. Number 13. H of x is equal to 4x minus 2. Find hx plus 2. Number 14. K of a is equal to negative 4 to the power of 3a plus 2. Find k of a minus 2. Number 15. G of n is equal to n cubed minus 5n squared. Find g of negative 4n. Number 16. F of n is equal to n squared minus 2n. Find f of n squared. Number 17. P of a is equal to a cubed minus 5. Find p of x minus 4. Number 18. H of t is equal to 2 times 3 to the power of r plus 3. Find h of 4 plus t. Okay? So you are going to answer this in your math activity notebook. So I hope that you have learned something in today's video lesson. So before I'm going to end this video, let's have a math code. You have here, Mathematics is the Music of Reason by James Joseph Sylvester. So thank you so much for watching, and don't forget to subscribe my channel. Bye!